Hello everyone, I am Dr. Sunita Dol. The topic covered here is source language issues of the unit runtime environment. In this video, we are going to cover various source language issues such as procedure, activation trees, control stack, the scope of a declaration and bindings of name. Learning outcome. At the end of the session, students will be able to distinguish between the source text of a procedure and its activation at runtime. A lot has to happen at runtime to get your program running. At runtime, we need a system to map names to storage on machine. Allocation and deallocation of memory is handled by a runtime support system, typically linked and loaded along with the compiled target code. A program is a collection of procedure. One of the primary responsibilities of the runtime system is to manage activation of procedure. Each execution of a procedure is an activation of procedure. If procedure is recursive, several activations may be alive at the same time. So in this section, we discuss about various source language issues which are procedure, activation trees, control stack, the scope of declaration and bindings of name. Procedure. A procedure definition is a declaration that associates an identifier with a statement. The identifier is the procedure name and the statement is the procedure body. For example, in Pascal code as shown on the slide, it contains the definition of procedure name read array on line number 3 to 7 and the body of the procedure is on line number 5 to 7. Procedures that return values are called function in many languages. A complete program is treated as a procedure. When the procedure name appears within an executable statement, we say that the procedure is called at that point. The procedure call executes the procedure body. The main program in the line number 21 to 25 calls the procedure read array at the line number 23 and then calls quicksort at the line number 24. The procedure calls can also occur within expression as on line number 16. Some of the identifiers appearing in the procedure definition are called formal parameters of the procedure. The identifier M and N on line number 12 are formal parameters of quicksort. Arguments known as actual parameters are passed to a called procedure. They are substituted for the formulas in the body. The actual parameters in the call to quicksort in the main program are 1 and 9 on line number 24. Activation tree. In most mainstream programming language, we have sequential program flow. Each execution of a procedure starts at the beginning of the procedure body and eventually returns the control to the point immediately following the place where the procedure was called. Each execution of a procedure body is referred to as an activation of the procedure. The lifetime of an activation of procedure P is the sequence of steps between the first and the last step of the P's body, including time spent executing procedure called by P, the procedure called by them, and so on. Each time control flows from an activation of a procedure P to an activation of procedure Q, it returns to the same activation of P. If A and B are the activation, then their lifetimes are either non-overlapping or nested. That is, if a procedure activation B entered before procedure activation A is left, then the control must leave B before it leaves A. A tree can be used called activation tree to depict the way control enters and leaves the activation. Each node represents an activation of procedure. The root represents the activation of main program. The node for A is the parent of node for B if and only if control flows from activation A to B. The node for A is to the left of the node for B if and only if the lifetime of A occurs before the lifetime of B. Figure 1 is the Pascal program for reading and sorting integers, while figure 2 represents output suggesting activation of procedure in figure 1. An activation tree in figure 3 is constructed from the output in the figure 2. The root of the activation tree is for the entire program sort. During the execution of entire program sort, there is an activation of procedure read array represented by the first child of the root with the label R. The next activation represented by the second child of the root is for the procedure quicksort with the actual parameters 1 and 9. During this activation, the call of the function partition and the procedure quicksort on line number 16 to 18 in figure 1 lead to the activations P of 1, 9, Q of 1, 3 and Q of 5, 9. The activation Q of 1, 3 and Q of 5, 9 are recursive and they begin and end before Q of 1, 9 ends. Control stack. The flow of control in a program corresponds to depth first traversal of an activation tree that start at the root, visit a node before its children and recursively visit children at each node in the left to right order. We can use a stack called control stack to keep track of live procedure activations. The idea is to push the node for an activation onto the control stack as the activation begins and to pop the node when the activation ends. Then the content of the control stack are related to the path to the root of the activation tree. When a node N is at the top of the stack contains the node along the path from N to the root. Figure 4 shows the nodes from the activation tree of figure 3. Figure 4 shows the nodes from the activation tree of figure 3 that have been reached when the control enters the activation represented by Q of 2, 3. Activation with the label are P of 1, 9, P of 1, 3 and Q of 1, 0 have executed to the completion, so the figure contains the dashed line to their nodes. The solid line marks the path from Q of 2, 3 to the root. At this point, the control stack contains the node S, Q of 1, 9, Q of 1, 3 and Q of 2, 3 along with this path to the root. The scope of declaration. A declaration in a language is a syntactic construct that associates some information with a name. Declaration may be explicit or they may be implicit. In Pascal and C, declarations are explicit. For example, variable I integer semicolon associate the type integer with the name I. Some languages like Perl and Python have implicit declaration. In Fortran program, any variable name starting with I is assumed to denote an integer unless otherwise declared. There may be independent declaration of same name in the different part of a program. The scope rule of a language determines which declaration of name applies when the name appears in the text of the program. In Pascal program, in figure 1, a variable I is declared thrice on line number 4, 9 and 13 and the uses of name I in the procedure read array, partition and quicksort are independent of each other. 2 occurrences of the variable I on line number 6 are in the scope of the declaration on line number 4 while 3 occurrences of variable I on line number 16 to 18 are in the scope of declaration of I on the line number 30. The portion of the program to which the declaration applies is called as the scope of that declaration. An occurrence of a name in a procedure P is said to be local to the procedure P if it is in the scope of declaration within the procedure P. Otherwise, the occurrence is said to be non-local. At the compile time, the symbol table can be used to find right declaration that applies to the occurrence of a name. When a declaration is seen, a symbol table entry is created for it. The symbol table should return the entry if the name is in scope or otherwise return nothing. Bindings of name. Even if each name is declared once in a program, The same name may denote different data object at runtime. The term data object corresponds to a storage location that can hold values. In programming language semantic, the term environment refers to a function that maps a name to the storage location, and the term state refers to a function that maps a storage location to the values held in those locations. Using the term L value and R value, an environment map a name to L value and state map L value to an R value. Environment and states are different. An assignment changes the state but not the environment. For example, suppose that the storage address 100 associated with the variables pi hold the value 0. After the assignment of pi equals to 3.14, the same storage address associated with the pi but the value held there is 3.14. When the environment associates storage location S with the name X, we say that X is bound to S. The association itself is referred to as an binding of X. If X is not of basic type, the storage S for X may be collection of memory words. A binding is a dynamic counterpart of declaration as shown in figure 6. Till now, we covered source language issues. Now pause this video and reflect on this question for a minute or 2 minutes and write your response. Once you return the answer to this question, then you can restart playing this video. The question is, in the program as shown in figure 1, what is the scope of variable A declared on line number 2? I hope all of you have completed this activity. The scope of variable A declared on line number 2 is the entire program, including all procedure, read array, partition and quick sort. This is the reference used while preparing this presentation. Thank you.